So, good evening all, and welcome to our November meeting of Ottawa RASC. For those who don't know you, my name is Mick Wilson. I run the circus here. So, special welcome to any of our new members or guests that are here, or anyone from other centres who might be tuning in. By the way, I have already once been accused of wearing my pajamas as if I'm planning a sleepover. That was him. He's always rude. It's very culturally insensitive. I mean, this is finest African attire. It was also left over from my clown outfit for last night, being Halloween. I thought it was proper preparatory wear for the outcome of the US election on Tuesday. So, thank you. Our special notice, anyone who parked in the main parking area, as in number 1 area there, is that right? Number 6, sorry, number 6 there. Sort of the default parking area that is not open tonight, and the fact that the machines were undercover does not mean that parking was free. So if you have parked there, you will need to scoot out and go to one of the other areas. Thanks. Okay. So usual stuff, I handle the intros and so on. Again, we're coming up to the AGM in December, so there's more business related stuff around nominations and vacancies. Then Dave will continue with the monthly skies. Jim, where is Jim? Okay. Right, he's moving his car. Good. So Jim will be giving us an update on solar observing setups. I've decided that Jim also needs to become our unofficial king of alliterations for the centre. He always tries very hard. Then we've got the break. Taras is doing a forecast on the Saturn ring plane crossing during 2025. We have a lot of observations. And so once again, I'm asking everyone, please remember those coming up behind you. Now, we are supposed to be finishing here at 9:30. They sometimes let us go a little bit long, but let's please not abuse our host's generosity there. And then we'll close out with the usual announcements, the upcoming observation challenges, the agenda for next meeting, and so on. And so with that, David, please. Yeah, okay, usual stuff about recording and so on. I think we're getting used to that. 94 new members in 2024. We're going to need a bigger slide there. Welcome to our 8 new members. And I will skip over this so Dave doesn't have to stand there, and we get past the business stuff, please.
Okay, as our organization is required, we have our annual general meeting, which will be held on December the 6th. This will be ahead of the regular meeting. It will start at 7:30. Regular meeting will probably start around 8:10. Notice will be sent out to all members by email soon and will be published in Astro notes and on the website. We're still working out the details on how we handle the online piece. But please watch your emails for that if you want to join us online. So I know you can all read this. This will be in the email, okay? You do have an opportunity. Those who cannot attend the meeting may submit a signed proxy to the secretary no later than 48 hours in advance of the meeting. And the form of proxy may be requested from the secretary. It's about an 8-page document. Good luck with that. Okay, I'm going to turn over to Stephen Norris, who's in charge of our nominating committee, and he's going to talk about the positions here. It's all yours.
Okay, good evening, everyone. One of the things that anybody who has served on council or in any one of the positions will tell you that you get more out of the society when you are actively involved in it. Some people are actively involved more in the participating in star parties and things. Others become part of the, call it, administration of it. It certainly has been rewarding for me, and I think everyone else will say it. As past president, I need part of the, probably my only duty, is to put together a slate of nominations. It's a minimum slate, though. Just because you see a name up here that is currently nominated for this position does not mean that that person has that spot. Not at this point. That is only confirmed, shall we say, at the AGM. All this means is, as a minimum, these people have been nominated. Anyone can stand for any one of these positions, whether or not there is a name there at this moment or not. So if you want to be a councillor, put your name up. A lot of people here are only on this list to make sure that there is some continuity. They'd love it if there was an election. Okay. The more people that put their name in the ring, the merrier. So I encourage you to do it. However, you will notice of particular interest is we are looking for a treasurer. That position is very important. We certainly encourage anyone with any financial background within the society to come forward and discuss it. Maybe you need a little more information on what it actually involves and what we're looking for. Happy to do so. Either contact Dave Chisholm, myself, Chris Tarrant, we'd be, or the existing treasurer who I mean, Richard would love to pass along things to you. So again, these are people who are currently nominated. If you're interested, let's get your name in here as well. Okay.
Okay, thank you very much, Stephen. So council will nominate, oops. Where are we at?
Yeah,
I went back.
These are the whoa.
There we go.
There we go. There are also a number of appointed positions. Again, we look to provide a slate of nominated names. We're looking for another national council rep in particular, as well as someone to handle our public star parties and our hospitality. So, but again, if you're interested in any of the other positions, don't be afraid to put your name in or talk to us. All are welcome. Again, get your nominations in to Chris Tarrant.
Okay, thank you, Stephen. I think Mick is up next. Whoops. What?
Okay, thanks, Dave. Thank you, Stephen. I'll just back us up a bit here. Okay, so the usual rundown of benefits of joining Ottawa RASC. Apparently 98 people have already been convinced that this is a good deal, so I'll just run through the normal spiel. My usual take on things, that is the membership, your fellow members and the guest speakers who come to these meetings that make the best added value for purchasing your RASC Ottawa Centre membership. Expertise in observing, cosmology, history of astronomy, it's all here. In the physical sense, we have our telescope library, which at the moment I think is approaching 40 telescopes available free of charge to members to borrow. You can try before you buy, consider whether as a entering novice, you really need a telescope at all. If you're looking to upgrade, what sort of kit might be best for you. We have the members-only observatory out near Almont, the Fred Lossing Observatory. There are members-only star parties there all year, usually once a month, rain, snow, or whatever. And you will, once you join, you'll find out the means by which you can avail yourself of that facility. Out the back here, behind the stage, is our media library with books, DVDs, and so on. Estelle, where are you? She's probably in the car park as well. The library will be open, thank you. So that's around the back here. After the meeting, you'll get lost in the curtains and then you find the library. You also get to participate as a member in a variety of certificate awards that are designed to develop your observing and recording skills as an astronomer. 3 publications are available to you. Our own nifty newsletter comes out each month, courtesy of Gordon Webster. Where's Gordon? No Gordon? Okay. So that's an email subscription. The Journal of the Royal Astronomical Society of Canada, bi-monthly, somewhat more academic publication, available electronically or at a slight additional fee in a print version, plus the Observer's Handbook, which has been coming out annually since about 1770, I think. It's an invaluable resource for the amateur astronomer. Seriously, it's used all around the world. You probably don't believe it. As a member, you get access to the RASC Ottawa Discord server. There's a variety of channels there on topics ranging from astrophotography through to eclipse planning and so on and so on. It's quite active, and it's a members-only list for informal dialogue. You also get access to our free licensing of the pro version of Astrospheric, the observer's planning tool that gives model-based projections on transparency, cloud cover, and so on and so on. It's a $60+ value. You get that for free as a member of RASC. So that in itself makes it worth considering paying roughly $113 a year for your normal membership. By the way, I was doing some historical stuff with astronauts, and back in 2005, membership of this branch cost $45. That's over 20 years ago, or 20 odd years ago, and the price has only basically doubled. This is very good value for money. People joining the club back then, there's no reason why $113 should be cause pain now. $107.50 for families, plus extra per head costs for each adult and child. And then as a student or anyone under 21, it's $72.40. Again, you get your Astrospheric license for that. So now, Oscar, please, some words.
Hey everyone, just one final reminder about the upcoming annual dinner meeting on November 22nd. Once again, we'll be having it at Algonquin College, Salon D, or I think it's Building D, but anyhow. Cocktail starting at 6, dinner at 7. It's a roast sirloin beef au jus, as well as grilled vegetable lasagna as a meatless option. And then all the fixins and stuff is all buffet style. So there's going to be salads and all kinds of stuff, charcuterie, cheeses, desserts, etc. We're gonna have a wonderful talk afterwards by Dr. Johnny Moores. Unfortunately, Dr. Rogerson has a conflict and can no longer attend, but Dr. Johnny Moores has assured me that he can deliver the talk on his own. He is a big boy. Let's see here. Yada, yada, yada. Ah, yes. Okay. So a preview of their talk, or his talk, I suppose. Our ancestors knew the 5 classical planets as wandering points of light in the night sky. Today, with 62 years of data from robotic explorers, we understand them, and many more newly discovered worlds as fully realized planets. But what would it be like to experience these planetary environments in person through our 5 senses? Drawing from our book, Daydreaming in the Solar System, we'll take you on a journey to explore the sensory experiences of visiting these worlds, enhancing our appreciation for the universe and Earth on a human scale. So it's a fascinating talk, I am sure, and Dr. Moores will also be selling copies of the book at the event. I've also got some nice door prizes lined up. Skywatcher is giving us a limited edition 25th anniversary SkyMax 127 Virtuoso GTI. So it's a 5-inch f12 Maktusov Cassegrain on a motorized alt azimuth mount. And Svebny is giving us an SV 50380 ED refractor, which will be nice. I've got a handful of books on astronomy from Firefly Books. Brian McCullough has donated a copy of Daydreaming in the Solar System by Dr. Rogerson and Dr. Moores. And as well as Astronomy Plus, which is an astronomy retail outlet in Montreal, is giving us a handful of gift certificates. So lots of good door prizes, great value for money, especially if you win one of the door prizes. And it'll just be a fun time overall. Just an opportunity to get together, have a drink, share a meal, some laughs, and hopefully some interesting talk. But yeah, hope to see you all there. $65 per person. I'll be selling some tickets at one of these tables during the break. So come hit me up, cash or credit or debit. I'll take your money in any form. And if you can consider donating some money to the club, that would be great. We are partially, to some small degree, subsidizing the cost of the tickets, just to keep prices more accessible to those who otherwise wouldn't be able to afford it. Look forward to seeing you all there 3 weeks from today. Thank you.
Beauty. Thanks, Oscar. As always, thanks for all your work. Also, the RASC calendars, we're still taking orders for those. Got the online details there. Fabulous gifts. A bit hard to get into a stocking, but otherwise great. Members in the news, alas, no news, not even from Andrea this month. So get back past the boring stuff, and it's time. Yep. What did I miss? Oh, sorry, that was me.
Yeah.
That was me. Sorry, as part of our annual cycle of festivities, there are a number of awards in the offing. Many of you are already familiar with these. For newer members, perhaps not. So, of particular note are the Rolf Meyer Award for Planetary Observing. This has been a fairly prestigious award for quite a number of years now, and we hope it continues to be so. So the candidacy for that, the planetary astronomers amongst you, and I get to pick who's best. The second is the Paul Commission Observer of the Year. Observations need to come to me by the middle of the month, 2 weeks' time. The rules say that I have the discretion to consider any of the presentation, any of the images that have been presented during our meetings, during the observation reports. And I'm being asked this year to also consider stuff that's been put on the RASC Discord. And so please point out to me, assume that I'm stupid, and point my nose towards anything that you would like to be considered for regarding either of those opportunities. And now, third time lucky, Dave Chisholm.
Okay, thank you, Mick. We did have a question come in when they were talking about the nominations, and somebody says, well, what do councillors do and what do national reps do? Well, the national reps are the conduit between our centre and the National Council, and they meet 4 times a year roughly. And it's right now it's all virtual, and it's an opportunity for us to send things to head office and for head office to send things to us. And it's a very good communications channel. And so that's what the national reps do, but they also sit on the local council, and we meet about 4 to 5 times a year, sometimes in person, sometimes virtually. And then the councillors are the wise persons of our organization that counsel us as to how we're running things as a group. And sometimes they will take on specific short-term projects as well from the council. So those are those 2 positions. Okay, so Ottawa skies for November. So first of all, tonight is the best night for observing. That's why we're meeting inside. Actually, it's cloudy out, so it's Ottawa. So what can we expect? It's a new moon tonight. Of course, we switched to standard time on Sunday, which means that we can start observing an hour earlier. And I really hope that we never go back to daylight savings time. And in fact, we were in the process of arranging a speaker, hopefully early in the new year, who's done some scientific research on the impacts of going to daylight savings time. It was quite fascinating seeing his paper. So I'm hoping to have him speak in January or February of next year. In terms of the other moon phases, November the 15th is a full moon. It's also a super moon. It's the last of the 3 super moons for this season. And it was known by the early Indigenous folks as the beaver moon, because this is the time of the year to set beaver traps. It's also been known as the frosty moon and the dark moon. We have 2 meteor showers. Now this first meteor shower is an interesting one because often a meteor shower, there's a single event that caused that meteor shower, but the Northern Torrens meteor shower is caused by two events. The first one is dust grains left behind by asteroid 2004 TG10, and the second stream was produced by debris left behind by comet 2P Encke. It's a minor meteor shower, 5 to 10 meteors per hour. And the first quarter moon will block all but the brightest meteors this year. And then we have the Leonids meteor shower. And this was, it goes in peaks, but this year we're expecting 15 meteors per hour. And the last big peak was in 2001. And this was left behind by comet Tempel-Tuttle, which was discovered in the... Oh, yes. Can you drag my picture down, Chris? Thank you. There we go. November 17th and 18th. There. Okay. So best viewing after midnight for that particular meteor shower. So the previous one, I'll step back a slide if I can. 4th and 5th. So that's coming up fairly soon. Okay, sunrise and set. You'll see there's a jump in the times here because of the time change. So we can start our astronomy earlier, which is great. We have Mercury is at the greatest eastern elongation. That means it's visible just after sunset on November the 16th. It's visible on either side of that date as well, but that's the best time to observe Mercury because it's before the sun rises. Venus is visible in the evening sky. And Chris, can you drag my picture back up? Thank you. And these are the rise and set times for the first and the end of the month. And Mars is visible in the late evening sky. Towards the end of the month, it'll be at a more reasonable time. Jupiter is visible in the evening and through the night. Saturn's visible in the evening. Uranus is visible in the evening and through the night. And at November the 17th, it will be out of opposition closest to the Earth. And Neptune is visible in the evening as well. And there is my cartoon of the month. Thank you.
Right. Always open to suggestions. All right, Jim. Who's still in the car park? Oh, hello, Jim. You're welcome to come to the podium, please. There you go. Thank you. If you need laser.
All right, good evening, everybody, and welcome to my talk tonight entitled Supersizing Your Solar Setup. Interest in observing the sun has seen a sharp increase in popularity in the last couple of years. This is due both to the steadily increasing solar activity. We're coming up to the peak of the 11-year cycle right now, as well as the recent solar eclipses that we've had. There was a partial just over a year ago, and of course, the total eclipse that we had in April. There are a wide assortment of equipments out there to help you improve your solar observing experience. And tonight, I'm going to give you sort of a brief overview of what's out there. Many of these products are made so that you can just add them to your existing telescope setup, which is a good way of saving some time and money. But let's begin with a quick review of exactly what it is we're trying to observe. The sun is made up of various layers. The outer 1/4 of the sun is called the convective zone, and it's a layer displaying a rapid conveyance of energy from the center out to space. We can't view the convective zone directly, but we can observe its impact on the layers above. The first layer we can observe is the 500-kilometer thick photosphere. This is the point where the temperature has decreased enough for free electrons to reconnect with atomic nuclei and allow photons to then head out into space unhindered. It's what we see as the surface of the sun. Above this is the 2,000-kilometer thick chromosphere. In this layer, the sun's magnetic field transfers energy back into the thin gas making up the sun's atmosphere, reionizing it and moving it around in beautiful but complex ways. At the top of the chromosphere, there is a thin transition layer, followed by the very large and very hot corona that we see during a total eclipse. The equipment I will discuss tonight is dedicated to observing the photosphere and the chromosphere specifically, from our vantage point here on Earth. My review begins with what I call level 1 photosphere observing. This can be accomplished using the rear projection method. Dave Chisholm gave a presentation on how to do this last spring before the eclipse. The method is relatively easy and safe and can be done with your existing telescope or pair of binoculars. With it, you can see sunspots. You can determine the sun's rotation if you watch it from day to day or from hour to hour. And you can track solar activity just like the scientists did in the 17th, 18th, and 19th centuries, if you recall the talk I gave back in January. But if you're looking for something more out of your solar observing, then you could move up to level 2. This involves the use of filters over the front aperture of your telescope. These filters are made of polymer film or glass that can be purchased, pre-built for your particular size of telescope, or you can build your own from raw materials. The materials can, however, be fragile, so it is important to routinely inspect your filters to make sure that they are still safe to use. Using an aperture filter, you see more detail, including sunspots, granulation, and faculae. The views you get will be much sharper and detailed than with rear projection. To show you what I mean, I have prepared some comparison images. The image on the left is the best picture I could find online from a rear projection setup. It's from a website called The Sun Gun. The plans to build it are all on the website. The other two images were captured by me a few weeks ago using a purchased glass filter on my 10-inch Ritchie-Chrétien scope. That's the image in the middle. And with a homemade filter using Baader Astro solar film on my 4-inch refractor. That's on the right. The aperture filter images clearly show more detail, with the Astro solar film producing the best image of the three. Now, this is not bad, but what do you say we take it to level 3? Level 3 involves the use of something called a Herschel wedge. The idea for this device was originally conceived by John Herschel in the 1830s. It uses a wedge-shaped prism to reject about 95% of the sun's energy out the back. There are several brands available today, all of which are meant to be used with refractors only. Using a Herschel wedge, you can see pretty much the same thing you can with an aperture filter, but they provide superior sharpness, contrast, and detail. They also produce a much brighter image, so they pair well with filters. I've prepared another comparison, this time between Astro solar film that you can get from Baader Planetarium and a Herschel wedge, and you can see the photos at the top of each of those two setups. Same day, same telescope, and same camera. The two images have very similar amounts of detail and sharpness. However, the wedge image on the right has noticeably more contrast. Hopefully you can notice that. I notice it. Note the large-scale patterns that are visible in the granulation with the wedge, but that are not visible using the film. That is just white light, no filters. You're kind of skipping to the next part. That brings us to level 4. She was not a plant, I swear. This is achieved through the addition of a bandpass filter. Filters can greatly improve the performance of any of the previous levels that I've showed you. But note that filters darken the view, so they work best with a Herschel wedge. Filters allow you to see sharper images and more detail and contrast, and can help you to mitigate bad seeing conditions. The string of lovely weather that we've had through the month of October has allowed me to prepare you some examples taken using different filters. The image in the upper left represents what you'd see with your eyes with no filter. I had a IR cut filter on because I was using a camera, and the camera can see well into the infrared where your eyes can't. So you can see that the image is quite nice, but it is a little bit blurry. Add a solar continuum filter from Bader Planetarium. It sharpens the image and enhances contrast. That's the image in the upper right. The G-band filter from Altair Astro, that's a UK company, does much the same thing, but it also enhances the visibility of faculae. That's the bright areas. Get the laser out here. That's these sort of bright areas kind of intermingled here, called faculae. For fun, I also tried throwing on an H-alpha filter, which is meant for doing deep sky imaging. And the result was also beneficial, with image sharpness improving over the non-filter view. Note that all of these images have been captured using a monochrome camera. But if you were to use them visually, you would note that there is a strong color coming from each of the filters. The color being noted in the green brackets beside each image. So green for the solar continuum, red for the H-alpha, and blue for the G-band. The last thing worth discussing is how much all of these accessories cost. I have prepared a summary table for reference that I will forward to Gordon for the monthly newsletter. The main takeaway here is that for enhanced photosphere observing, we are talking about tens to hundreds of dollars. So not so bad. The same cannot be said for chromosphere observing, which we are going to talk about next. Level 1 chromosphere observing involves the use of calcium K filters. These are typically a filter added to your existing telescope setup, but they require at least some amount of energy rejection to be included as part of the setup, such as using a wedge or an aperture filter like I showed you earlier. Because the calcium K absorption line is in the UV part of the spectrum, it is meant for use with a camera, not with your eyes. You'd have to be a teenager to be able to see that far into the UV. Using a calcium K filter, we can see the lower chromosphere, complete with sunspots, megagranulation, plages, flares, and on a good day, prominences. Level 2 chromosphere observing requires the use of very narrowband hydrogen alpha filters, specifically a device called an etalon, which delivers band passes as narrow as 0.7 angstroms. The devices are tunable to account for Doppler shift of the fast-moving gases that you are trying to observe. They are available in the form of dedicated solar telescopes or as add-ons to your existing telescope. With these devices, you can see the mid and upper chromosphere, complete with sunspots, fibrils, spicules, plages, prominences, filaments, and flares. Oh my, a veritable smorgasbord. Before I show you some comparison photos, I thought some of you might want to know more about how a hydrogen alpha solar scope works. At the front, there is typically a red energy rejection filter that knocks down a big chunk of the energy coming into the scope. Behind that is the etalon, a very accurately ground piece of glass with a semi-reflective coating on either side. Light wavelengths that are integer multiples of the glass thickness are passed through the etalon by way of constructive light interference, while all the other wavelengths are reflected away. This produces a response that looks like a comb with many, many very narrow passbands. These bands can all be shifted down together in wavelength by tilting the etalon, effectively increasing the thickness of the glass. Alternatively, on the more expensive versions, you can heat up the glass and cause it to increase in thickness. The most popular, most affordable versions, though, use a tilt type device. So behind the etalon, there is the blocking filter, which has a precisely defined passband that allows only the one etalon passband corresponding to hydrogen alpha to get through. Stacking these three components together gives you the single narrow passband you need to observe the chromosphere. As with the photosphere, I've also prepared some comparison images for the chromosphere observing. The left two images were captured using calcium K filters of various bandwidths, and the image on the right was captured using an H alpha setup that has one etalon. There is clearly an advantage to using a calcium K filter with a narrower band pass, as details are much better defined in the 2 nanometer wide image. Although there are many shared features between calcium K and hydrogen alpha, there is clearly a lot more going on in the hydrogen alpha image. These differences are further illustrated when we zoom in to the full resolution of those images that we just saw. The active regions are well captured in calcium K. That's basically everything. The sunspot and the bright plages, that's all considered active region. So that's where there's an increase in magnetic activity. So calcium K shows that very well. However, the movement of the chromospheric gases in the form of spicules, fibrils, and filaments, they are only visible using H alpha. Yes, I'll try. 1, 2. There, that one. Yep. This right here? That is a filament. So that is, so you know what a prominence is when we see gases that are trying to escape from the surface. So that is a prominence as viewed from above.
And it's coming up like that because the gas is cooling in the dark.
Correct. So it appears darker. And then we'll kind of see it a bit in the next slide, but we're still seeing light from the photosphere getting through. So the face of the sun looks brighter than the filaments and the prominences, but that's what going to the next level is for. There's always another level to go to. So where was I? So what, pray tell, does level 3 chromosphere observing involve? Well, how about stacking 2 etalons together? Doing so further narrows the passband to less than 1/2 of an angstrom for an additional improvement in contrast. By doing so, the brightness of the solar disk is reduced, allowing for dimmer features like filaments and prominences to stand out better and be easier to see. Using a double stack, you can see all the same things as a single stack, but with more contrast and detail visible. It so happens that I purchased a second etalon just this past June to form my own double stack with my existing setup. These 2 images were captured with my setup to illustrate the differences, single stack on the left and double stack on the right. Notice how the solar disk is darker in the double stack image, resulting in an accentuation of the bright plages. Again, that's the these areas here, the active regions, they're more pronounced now. But also, the dark filaments are more visible. So this is now stands out quite starkly, as well as over on the left limb here that you can barely see in the single stack. The effect is perhaps even more visible with these comparison images that I took back in July, shortly after I had purchased the second Etalon. You can see, especially in the limb image, there's filaments visible all along here that you can't even see in the single stack. Also note that the double stack image, in the double stack image, the sunspots are much less prominent. In effect, the double stack is more effective at blocking the light that's trying to get through from the photosphere, allowing just the chromospheric light to be observed. So that seems pretty good. But as with most things in life, you can always go bigger. In this case, I'm talking about level 4 chromosphere observing. This involves moving up to scientific grade Etalons or spectroheliographs, like those used by the 20th century scientists I told you about in my January presentation. These devices give extremely precise and narrow band passes, and thus deliver superior contrast and detail. It is also possible to observe absorption lines that other than calcium K and H alpha, especially when we are talking about the spectroheliograph, which is the odd-looking device shown at the right of the slide there. Using these implements, you can see pretty much whatever you want. Any aspect of the photosphere or chromosphere can be dialed in and observed from where we are here on Earth. I pulled a few examples off the internet to show you what is possible. The image on the left was taken using a Daystar brand calcium H device, another absorption band on the sun, through a 12-inch aperture refractor, which I'm sure all of you have just laying around. The image in the middle is an H-alpha image captured using the Astro brand spectroheliograph. And the image on the right is of helium D3 emissions, not absorption line emissions, captured using a do-it-yourself spectroheliograph called the Solex, plans for which you can find online. And as a side note, the Astro brand spectroheliograph that I ordered should arrive sometime around Christmas. More on that at a later date. In terms of cost, chromosphere observing is much, much more expensive than photosphere observing. We're talking a factor of 10 to 100 times more expensive. The reason for the large increase in cost is the requirement for expensive, high-precision filters and the machining that houses them. It will be interesting, however, to see if the trend towards high-quality but less expensive Chinese-made astronomy equipment that we have seen in recent years eventually makes its way into the solar observing market. As you can see on the list here, the Chinese company Antlia has very recently entered the market with a whole line of calcium K filters. So I am hopeful that that will continue to prosper in that field of cheap solar observing. Well, relatively cheap. So in closing, I have presented a review of the broad range of accessories that are available today for improving your solar observing experience. Most of these accessories can be added to your existing setup for enhanced results. The least expensive layer to observe on the sun is the photosphere, on the order of 10 to 100 times cheaper than the chromosphere. The sun is a dynamic and easily accessible target, well worth our attention. I encourage everyone to give it a try. Thank you.
Beauty, thank you. Questions? Hi. Here he is. He's a good boy. Okay. Who's got a question? Over here. On the line.
Yeah, I recently heard that Mead and Coronado have gone out of business. Can that be confirmed?
Yes, all indications are that Mead has bounced around for a number of years. Coronado is one of their product lines, and they've gone bankrupt and been bought up and bankrupt and bought up. Most recently, they were bought by Orion Telescope, a Chinese company, and it recently laid off all of its staff in North America and took down their website. So that's not promising. Well, fingers crossed that that product line, the Coronado scope, will maybe split off and continue. But at the moment, Lunt is really the only provider of hydrogen alpha telescopes that you can reliably order things from.
A question here. Jim, do you mind going back to your slide just before?
The one just before?
Yeah.
Try.
Oh, can you? Oh.
The price one there, yeah.
Yeah. So I have a question, but I wanted to say that for the Lunt calcium diagonal, I was told by Lunt that if your refractor is under 100 millimeters, you don't need an ERF.
Yeah, that's correct.
And also, I have a question about the Antlia ERFs, because the ERF you would use for calcium isn't necessarily the same one you would need for a hydrogen alpha, right?
That is correct.
Unless it's a dual band one, and I don't know is that what the Antlia one is, if you know.
Yeah, not included in this list. Antlia also has these multi-band solar observing filters. They have energy rejection filters built in. I don't think they serve much purpose. They're just going to show you the photosphere, so you might as well buy a much cheaper G-band or something. But I've noted here in the table when things include an energy rejection filter as part of the assembly. In most cases, if the filter is narrow enough, it acts sort of as an energy rejection filter.
Oh, that makes sense. Thank you.
Anybody else?
And yeah, the telescope size limit, that is something to be noted. I didn't include it, but most of the time they say it's 4-inch refractor or less, or else you have to add an additional energy rejection filter. Anyone else up there?
If you're using a scope with, I don't know whether you're level 2 or if you don't have an energy rejection filter or some other filter at the front, what happens with the telescope if it's slightly off axis to the sun? Will it burn through the side of the scope body? I mean, unless you remove the energy at the beginning, even if you have a Herschel wedge, you could still burn the inside of your scope, couldn't you?
Yes and no. So using a reflecting type telescope without a earth on the front is frowned upon because the heating of the secondary mirror can be a problem. In a refractor, Typically, the focus point is well outside of the telescope. So, I don't know if you know what I mean, like where you would achieve focus is past the inside of the scope. So the energy from the sun, and again, we're talking about limiting the size of the refractor. So the total amount of energy coming in is initially limited by the size of the scope, but also you're not focusing it to a point. So the temperatures that you're talking are manageable. That said, you know, you shouldn't be trying to fiddle something yourself. You should, you know, go with what has been specifically made for this purpose to make sure that, you know, everything is going to work okay and you're not going to damage your telescope
Or your eyes.
or your eyes. Yes. Does that make sense?
Any other questions?
Any other questions? Can't see any.
I don't see any more.
All right. Thank you very much, everyone.
Okay, thanks again. Thanks. There, those are your closing remarks. And your questions. Okay, break time. Rest of the museum is closed. There is another event going on the museum side, so probably don't want us wandering around over there. We do have some door prizes this month, so I'll be giving out the tickets for those. And how are we doing for time? I think we're at 8:30. So, okay, so you got 14 minutes. How's that? 15. Let's make it 15. Okay. Okay. Oh, and your trivia question, Hydra is the largest constellation, covering 1,303 degrees approximately. What proportion of the celestial sphere is that area? All righty. No. Okay. So, given that that is not the correct answer, does anyone in the room have a better even estimate, guesstimate? Who looked it up? That's cheating. Yeah, probably a typo. Well done. Psychology of hacking. That's all right. So, Taras, present yourself. And everyone has been very, very good about sticking to time so far, he said, hintingly.
During public outreach, there are two objects that undeniably never fail viewers' expectations: the moon and planet Saturn. What seems like a star to unaided eye suddenly acquires a well-known and recognized shape, which even small kids know as the planet if looking at it through the telescope. My personal experience was awe-inspiring experience, surprise, when the ring planet showed up in my eyepiece when I was doing the 3-star alignment during my first telescope's first night session. Since then, I tried not to miss a chance to observe the planet, and anytime it was high enough in the sky, and take pictures of it if possible. So this is one of them. I took this with FLOS Observatory 18-inch Starmaster telescope on September 19th. What makes Saturn prominent is obviously its rings. The the diameter of the rings, they span about 282,000 kilometers across, but they're only 1 kilometer thick, or 3,200 feet. The rings are made up of billions of small chunks of ice and rock, ranging in size from dust to chunks size of a house or a mountain. Other fascinating facts are the Cassini division is 4,700 kilometers gap between rings A and B. The rings orbit the planet at different speeds. The rings are primarily made of water ice, but also contain other materials like methane, ammonia, carbon monoxide, molecular nitrogen, and carbon dioxide. The rings are so thin that if you had a model of Saturn that was a meter stick wide, the rings would be about 10,000 times thinner than a razor blade. So it's easy to notice that the rings look different as the time goes by, different times. This collage was made of pictures of planet roughly around its position every time, almost every year. Starting with 2018, this is top left image, until August 24, bottom right. The only year that is missing is 2019. The planet was just so low that I couldn't image it with a decent quality. So we see how the rings changed their angle from very steep in 2018 to almost edge on this summer. And there is quite obvious explanation why. It depends on our point of view. Saturn's axis is tilted at an angle of 26 degrees relative to its orbit around the sun. It's called axial tilt. It remains permanent and doesn't depend on the position of the planet along its orbit. I tried to illustrate it in this animation, in this 3D model, which is obviously grossly out of proportion, but it illustrates the concept, I hope. So our view of the rings will depend on where we are as observers on the Earth, and with regard to the when we observers on the Earth are with regard to Saturn's position on its orbit. If you look in the direction of red arrow in this picture, the rings will be not under the same angle as when we looked in the direction of the green arrow. Of course, the same as time goes by, Earth will also be in a different location on its orbit and this picture, but this picture doesn't demonstrate it for simplicity. So in the 3D modeling software, I placed the camera on the surface of the planet, and I think this one, right? Oh, it's all right. This one? Yeah. Yeah, so camera is right somewhere there on the surface, and this is what we look at, our field of view. This is the result of what the camera would see. So from that perspective, where the red arrow was pointing, this will be our view, and this is more or less almost edge-on appearance for the rings. Well, it's quite obvious that from the opposite or other angle, the rings will change. And I thought that's about it. I thought that's what it is. And the rings just go like this, change their position. So it takes about 29.5 years to complete one revolution. This is more or less the period of full cycle when the rings change their position. As Saturn circles the sun, the angle of Saturn rings relative to the sun varies by 26.7 degrees, which is that axial tilt. Twice during 29.5 years, the rings are edge on to the sun. So it looks like it's approaching now about that time when this could happen, and the rings will be edge on. This event is called plane crossing. It sounds too simple to be true, actually. So when you compare these two pictures, I took them on August 8th this year from Starfast, and then about more than a month later, in September, you see that almost edge on in August turned out to be much steeper edge angle in September, just a little bit more than a month later. So it's probably something going on, and it looks like maybe the crossing event had already happened, or maybe something else, maybe we missed it. Apparently, we didn't miss it. Because the model and the explanation was very simple and didn't account for other things. Model didn't account for the fact that the plane of orbital plane of our Earth and orbital plane of Saturn are not in the same plane. There is a 2.48 degrees inclination between the orbits. And also on Earth, we are not always in the same location, but the Earth has its own tilt, about 23 degrees. So there is a fact of parallax which becomes apparent when the planets move along their orbit. It would be rather difficult to model it all in the simple 3D modeling software that I was using, but there is no need because this modeling is done already by other applications like Stellarium, which can account for these and other factors as well, and provide us amateur astronomers and photographers with very precise predictions of what the planet view would be like. So this video I captured by recording Stellarium screen in fast forward mode. It covers the time span from 2017 to 2031, roughly half cycle, and it shows how the angle of the rings did change and will change within years, and also how angular size of Saturn changes depending on the distance between Earth and the planet, as both of them traverse their orbit. The retrograde change of angle, like the one I mentioned earlier, is noticeable too. The retrograde change can cause, in some cases, not one, but 3 Earth crossings. There must be an odd number for that during any half orbit of Saturn's 15 years, and that half is about 15-year period. We would almost have these 3 crossings this year in the middle of November 2025, but they're not quite there. They will be very close to crossing the plane, but probably they may look just as a very thin ring, but not completely, the ring would not completely disappear. We would have to check that in late November 25th. Let's watch the video again and see if you'd be able to catch that moment. Oops, I think it's play. Thank you. Yeah, so you see as the years progress, there will be a moment mid of summer 2024 when the image was taken from the Starfast, and then that retrograde motion which we observe now, so like right now, and then retrograde again, and this would be already March 2025 when the rings actually will cross the plane. So when when there is only one crossing like this, what we would have, and the Earth will be almost the opposite side of the sun. Therefore, making observation to see how those rings would disappear would be very difficult, practically impossible. So the next occasion when this happens, the crossing on March 23, 2025, the Saturn will be only 10 degrees west of the sun. Earthbound viewers won't get a ringless view of Saturn until triple passing of 2038-39. So this triple crossing will happen in around that time. However, during November 2025, this almost crossing event that you saw, the planet will be away from the sun on the opposite side actually, and we'll be able to see this almost disappearance of the rings in quite good conditions. So Saturn will be about 40 degrees above the horizon, and around midnight, we should be able to see it. So be sure to check the rings then. Thank you.
Any questions for Taras? And thank you, by the way.
November, for the crossing would be actually a couple of days, mid-November to second week of December. And again, that would be 2025, right? Mm-hmm. It's a good question. I didn't see it myself.
When the crossing happens, is it the rings literally disappear from view? They can't be seen at all?
I can't answer because I didn't see it myself. I saw pictures published. There is a Hubble website with a previous event like this was 1995. And they're very thin line, but what's prominent is that the size of Saturn's satellites, moons, is actually slightly larger than the thickness of the rings. So the picture did show the moons crossing that location where a very thin and faint ring was. But according to the scale of the picture which I saw, I would say I'm really interested to see what it would be like when it happens, at least with this like almost crossing.
Thanks, Taras. Anyone else? Okay.
Thank you.
Okay, so now it really is an observation heavy type meeting, isn't it? So if Chris, stop fiddling around there, can we just go back to the list, please, Chris? Okay, so the order of battle, you can see before you there. Again, I'm asking everyone to be aware of those coming after them. If needs be, we might need to trim the list in order to not upset our hosts. So please, over to Bob.
How do you do? This is from, I'm calling you from Saskatchewan, which is not 23 degrees Celsius right now. The Pac-Man Nebula is a bright nebula found in Cassiopeia. We don't see red very well. So this nebula appears very faint in a telescope, is about 9,500 light years distant. Because of its shape, the nebula is named after the video game character. In my photo, some of the faint nebulosity shows up, which ruins the obvious Pac-Man look. Next, please. M33 is a large nearby galaxy found about 3.2 million light years distant and containing about 40 billion stars. It is reasonably close to the Andromeda galaxy and may be a satellite of it. The galaxy is visible to the naked eye for those with very good vision and in a dark environment. It was first spotted in 1654 by an Italian astronomer and was added by Charles Messier to his list in 1764 as M33. The red areas in my photos are high in hydrogen and are star-forming regions. They show up best in hydrogen alpha photos, so I'm delighted to see them in my RGB photo. Next photo, please. NGC 7380 refers to the open cluster of stars you see in this nebula. The nebula itself is an emission nebula and is extremely difficult to see visually. It only shows up in photographs. The nebula is about 8,500 light years distant. At the center of the nebula is a star that is actually a double star containing two massive young stars. They are ionizing the hydrogen in the area, creating the red color. The shock wave from the stars is creating new stars in the nebula. Thank you very much.
Beauty. Thanks, Bob. And now to Oscar, please.
Hey everyone. Got a couple images here to show. This first one is of the Ophiuchus cloud complex in Ophiuchi, right adjacent to Scorpio. So this is 2 hours and 41 minutes of exposure with a ASI 2600 MC Pro using a Canon 70-200 telephoto lens. I think I had it at 70 millimeters focal length. So I took this mostly from FLO. I think the hour and a half of it was at FLO, and the first bit of the data I collected was out on Manitoulin Island. So it's a nice object, lots of colors, lots of dark, cloudy stuff. It's fun to look at. Before I go on to the next image, I just want to, if anyone already bought a dinner ticket, please come and get it from me after the meeting. I'll be using the numbers on the tickets for door prizes at the dinner, so it's important to have your ticket. All right, now that with that business concluded, next image. Am I not hitting the right remote? I am not. There we go. My name disappeared now. Perfect. There we go. All right. So this next one is the Elephant's Trunk Nebula, IC 1396. This was shot in narrowband with the SHO palette. It's called the Elephant's Trunk because you've got this little thingy here that kind of looks like an elephant's trunk reaching out. Sorry, let me take a look at my notes here. It's a concentration of interstellar gas and dust located in the constellation Cepheus, about 2,400 light years away. Yeah, it's this was 17 hours and 18 minutes of exposure, 3 hours and 48 in luminance, 535 in sulfur, 550 in H alpha, 5 hours in O3. And my last image of the night. Oh, the stars disappear. I forgot about that. But I like doing this with images because I find the stars distract a little bit from the structure of the nebula, and it's a lot easier to see some of the, some of the cool sort of dark blobbies in the nebula when the stars aren't around. I can put them back. Can I go back using this remote? So here's stars on, stars off. Wipe on, wipe off. All right. Oh, wipe back on. All right. Next one, the Iris and Ghost nebulae. So I thought shooting the Ghost would be appropriate given that Halloween was yesterday. So I devoted a couple of the nice nights in October, 5th, 7th, and 24th to image. This one, a couple of years ago, I displayed an image of the Ghost Nebula, which is this fun guy over here, that I had shot with my 11-inch Schmidt Cassegrain of just the Ghost Nebula. I'd never actually realized exactly how close it was to the Iris Nebula, but it's just the Iris Nebula is just hanging out right here. I think there's only 2 degrees of separation between them, I believe. They're pretty close to each other. So the Iris Nebula is also known as NGC 7023. It's a bright reflection nebula in Cepheus as well. The designation, the NGC designation is actually for the star cluster that the nebula surrounds. And then the dark areas of the nebula, so these ones specifically, are cataloged as LBN 487. This whole cloud complex is about 1,300 light years away from us, and is about 6 light years across. So this was 19 hours and 40 minutes of exposure, an LRGB using a 2600 Pro, and a ZWO FF80 refractor. So it was 5 hours and 6 minutes in blue, 3.5 hours in green, 3.5 hours in red, and let's call it 7.5 in luminance. So let's do some more wipe off, wipe on here. Stars? No stars. So you can see how much dust and nebulosity is in that area that kind of gets hidden behind the stars. So we'll bring the stars back. I made no alteration to the brightness of the image at all when I remove the stars, but it just a lot more obvious when the stars are gone. But yeah, that's it for me this month. Thank you.
Thank you, Oscar. Next up, Andrea. Nice shirt.
Thank you.
Goes to my pants.
Forward, backwards. Oh, wrong way. Still the wrong way. Oh. Okay, a lot happened this month. I'm not going to talk about every image. I put a lot more detail in my Instagram posts, including how I took these images. If you have questions about how I took any of these photos, come to the Discord. You can ask me, and I have a lot of detail on my Instagram in particular. So it began by looking at all these very exciting sunspots, and I have been using a Power Mate, which is like a Barlow, and you can, like, I didn't have to buy a new telescope. I just got a Power Mate, and that was cool. So many clear nights. I did a lot of deep sky. I actually have an image of the ghost as well. This is the cave done without any narrowband filters, just RGB imaging, which I thought was amazing. I did a full moon alignment. It was a Photo Pills World meetup with all kinds of photographers. We all met at 2 specific spots. And if you ever want to know more about Photo Pills, I can tell you about it, but it helps you do solar and lunar alignments. Of course, I tried to take a picture of the comet. This was up at the lake, Lake Huron. This is a stacked image of about 2 hours. I used a tracker and 85mm lens on a camera. Of course, we had the incredible aurora, geomagnetic storm in October, and I took lots of photos. I tried to get reflections. I have 3,000 photos. I've gone through most of them, and my card reader died several times when I tried to upload them. This is actually the SAR arc, and I have a description of this in my Instagram post, but it's not red aurora. It was seen across North America and all the way south, but it's actually a slightly different phenomenon. The SAR arc is called stable red aurora, but it's actually not stable and it's not aurora, and it comes from something to do with the ring current. But you see it here. It was so visible in this particular geomagnetic storm. You'll see it as well in this video. You'll see it in this video. It's purple. So this was one of my 500 time lapses. And that magenta little bit is the SAR arc. And these were just some other people I met on this bridge. Well, that was just one of the many time lapses from that night, and I think that's the end. Is that the end? Yes, that's the end. Then yes, I needed to sleep after all of that.
Thank you, Andrea. Jim, again. There you go.
Hopefully you're not getting sick of me. All right. So my first image is of active region 3839 3842 and 3844. We saw them earlier during my presentation, but this particular view is with a 2.5 times Barlow added. This is with the G-band filter and the Herschel wedge on my 4-inch refractor. The shot is a stack of the best 200 frames out of 4,000, stacked in AutoStacker 3 and sharpened in IM-PPG. I am pretty happy with the results, considering that the seeing conditions from in the middle of the city are almost always below average. This next is a time-lapse video that I made during that big solar storm on the 10th and 11th. It's an assembly of single exposures taken with a Leiwa 4mm fisheye lens and an ASI 585 camera, one image captured every 10 seconds. The video is just under 12 hours of real-time duration, so we're going to see the whole event in 6 minutes. So let's take a look. It's just the green button to go. Yes, it is. So the stepping up in brightness, that's the camera's auto gain and auto exposure, adjusting itself as it's getting darker and darker. And if you look carefully, the clouds are starting to turn green. So the aurora was actually already going on during the daytime. And as soon as it was dark enough, you could see it. And this is from my backyard in the middle of Ottawa. And I was a little bit unhappy that there were clouds, but then the clouds went away. And it was very cool. You could actually, at some points, see this naked eye in the city. I'm sorry I don't have dramatic music. Yeah, there's some satellite traffic. There's planes going by, airplanes. There's a helicopter at one point living near the hospital. And you can see the auto gain has to adjust up and down as the brightness of the event changed over the course of the night. The colors are a little bit odd because this particular setup, there was no IR cut filter on the camera. I need to figure out how to do that with this setup. It's a bit of a jerry rig. The lens is meant to go on a mirrorless camera. Oh, there's a good spot. That was around 10:30, a bright outburst. It was, I took the dust cover off of the mirrorless camera lens. I cut it apart and I epoxied it to a T-thread adapter. And yeah, that's what I did. And it works okay. The problem is the spacing. The lens being meant for a mirrorless camera has very, very short back focus. So getting it to work with a traditional imaging camera for astrophotography was very difficult. But yeah, you'll notice that even when doesn't seem like much is going on, that the aurora is still active. The scintillating effect was very fascinating. It kind of reminded me of I don't know if you've seen Forbidden Planet, the monster, the effects they use for that. It reminded me of that. Yeah, and there's another outburst there. That was after midnight, I think. The flashes of light you see on the left, or the right rather, that's traffic on Alta Vista. Somebody posted on the Discord that they could help me with that porch light. My neighbor's backyard. Yes. Oh, that was I think it was a slingshot and a rock, just to be civil. One thing that's kind of cool, you notice how the trees look kind of glowy purplish color? That's because leaves reflect infrared. And so they have that odd color because the camera is seeing infrared. It's kind of neat. Yes, and from the ambient lighting. Because there's still incandescent light that's being used to give off a lot of infrared. I laughed when you said you had thousands of images, because this was over 7,000 frames, 4K, and yeah, it took a day just to downsize them to HD, and then another half a day to assemble the video. I'm just saying. Very hard on the computer, yes. So yeah, there's another patch of clouds. This was starting to get close to morning. I was long asleep by now. But even still, as you'll notice, more satellites are visible as we get close to morning. But the show is still going on. See, there's some satellites there. And there. I was very impressed at the duration. Like, it was basically nonstop. More of the activity, I think, was seen if you were in Europe, because the storm started basically around noon on the 10th. You can see daylight is coming. There we are. So there, you just saw the whole thing. I've got one last image, I think. Yep, no, 2 images, sorry. No, you can just sit there and make me feel uncomfortable. That's fine. This is from my third and final attempt to see the comet, 2023 A3. I was lucky to have near perfect viewing conditions from my in-laws' rural Quebec farm on October 13th. So I was able to get a really good look at it. It was clearly visible naked eye about an hour after sunset, and it was quite spectacular viewed in binoculars. Even the anti-tail was visible in binoculars. This particular image is a single 15-second exposure at ISO 800, captured with a Canon M3 mirrorless camera and stock 18 to 150 zoom lens. I like the fact that the waxing gibbous moon was up, which gave me lots of time to get my camera pre-focused, and it also illuminated the colorful fall leaves that you see in the foreground, made for a nice image. I'm still a little unsure, though, whether I should feel happy or sad that nobody noticed that I was missing from the dinner table for a period of time during Thanksgiving dinner.
I'm thankful.
My last image is from a fun EAA session I had on the 24th. I was using a surplus Computar medium format 105 to 150 zoom lens. Why I was doing that, I have no idea. And my Cam DS432 camera with a 2.5 nanometer H-alpha filter from my backyard in central Ottawa. This mosaic shows most of Cygnus captured in 4 frames, each a live stack of 21-minute exposures. There are numerous cataloged deep sky objects in view, including the North American nebula there on the left, the Pelican, a couple of sharpless objects, the Northern Coal Sack, that's kind of the dark blob between the North American and IC 1318. You can see the Crescent Nebula on the right, and also the Tulip Festival way out in the far right. When viewing such a beautiful section of sky, I think you can probably understand why I have such a love of mini refractors. And the what? Quiet you. And the wide fields of view that they deliver. Thank you.
The medical term for an obsession with mini refractors is hereby said to be Thompsonitis. It's a behavior issue. That's Jim, over to you.
Well, hello there.
Hello.
Very good. Hi, everybody. So this is a crop image of the Helix Nebula. And I had a clear view of it a couple of weeks ago from my balcony. I used a Sharpstar 94mm refractor, Malincam Skyraider camera, and my trusty Ideas MBX filter. I was also fortunate enough, because I have an Alt-Az mount, I was able to take advantage of the SharpCap program, which has a very good live stacking algorithm. So it allowed me to stack this object for 30 minutes, which is quite long for me anyway. The image was post-processed using Topaz Studio 2. Just a little bit about, little information about the Helix. I won't go into it too much. It's in the constellation Aquarius. It was discovered by Carl Harding in the early 1800s. And the nebula is approximately 650 light years from Earth, which is one of the closest planetaries to Earth. And as you could see, the stars, the dusty outer layer of the nebula is unraveling into space and glowing from the intense ultraviolet radiation from the central white dwarf. Now we're on to the next image. Green, right? Green again. Oh, there it is. Okay, so this is an animation of the solar prominence taken a couple of weeks ago on the same Alt-Az mount. I was using the Lund 60mm H-alpha scope with a double stack and the ZWO ASI 174 mono camera. As you could see, the images are inverted to highlight the detail. And I used the program Firecapture to take a series of 1,000 frame videos or SURF files every 30 seconds for 70 minutes. And the data was then processed with auto-stackered IMPPG, PIP, and Affinity Photo 2. And while a good deal of work time goes into putting this together, I continue to enjoy seeing the sun in action and how it changes over time. Thank you.
Thank you, Jim. Next up, Paul.
All right. Keep it short. Okay. Keep it short so I can't read all my, no, okay. All right. I will keep it short. I'll talk fast. So good evening, everyone. I hope you had a chance to get out in October and September, obviously, for the beautiful skies and the warm temperatures we've had. It's been a busy month, certainly for me celestially. The comet kept me very busy. I saw it on 13 different occasions, and I'll be assembling a time lapse to show how it's changed in shape and brightness over that period of time. In the meantime, we had this beautiful display, but I'm going to start with the comet first. I showed this picture in September just to put things in context. For those of you that may have tried to see this comet, it wasn't easy. It wasn't easy in our part of the world. What they say in real estate, it's all about location, location, location. At 45 degrees north latitude, we had to battle with the comet being at relatively low elevations above the horizon, and therefore you're looking through thicker layers of air. So if you were wondering what all the hype was about, but you looked at it and you could say, oh, I barely see it, you weren't alone. There were a few nights where we had beautiful skies in our area, but we also had to battle with the moon. The moon was up until past the time where the comet was closest to the Earth, and it only started to clear once the comet started to get smaller and smaller. So bit of a challenge. That was September. I went out on October the 10th. Technically, the comet was not, might have been visible under unrealistic conditions. I went out to Silver Lake and I thought, I'm not going to see the comet because at this point in time, sun was down about 6 degrees below the horizon. The sky was still quite light. I was hoping to catch the tail, but no tail available. That would have to wait for a couple more days until the comet got up higher. But as I was packing up my equipment on that day down at Silver Lake, I noticed around 7 o'clock or so, when the sky got a wee bit darker, 7:15, that the sky became quite red. And this was while the sky was still, relatively speaking, quite bright. And I thought, oh my God, what am I seeing here? And it was the aurora that folks had talked about. It was beautiful there down at Silver Lake. It gave me a nice view over the lake. I stayed there for about probably about an hour and a half, and took various photographs. And then it started to die down a bit. I thought, well, that's pretty cool. I'm going to pack up my gear and head back home because I still had to drive to get home and see if it's still active when I get home. So I did that and packed up my gear and then started heading home. But about halfway home, down near the village of Balderson, I was looking out the windows there and of the car, and I'm going, the sky has become very bright. And so I pulled off on a side road down near Balderson and got out, and it was crazy. The sky exploded with color. One thing I have to say, I suffered a major failure of my imaging computer this month, which has delayed things like FLO training and that. But in this context, all the images that I'm going to show you, especially the aurora here, are unprocessed. They're as they came out of the camera. The colors on this aurora were insane. I've watched aurora ever since I've been interested in astronomy when I was about that big. This is by far the brightest, most dynamic display I'd ever seen, including the one we had on May the 10th, which was very, very impressive. But this thing, as Jim pointed out, this was active like during the day. And by the time I wrapped up that evening, which was about 3 in the morning, it was still going strong. It was crazy. So I'll show you a few images that I captured. This is from an all-sky camera, Mariko Theta X, and it really covered the entire sky. It didn't matter what direction you looked in, you got auroras. And that color is, as I say, that's how it came out of the camera. It was so vibrant. I mean, I've seen color displays of auroras many times in that, but the way this aurora changed, like it morphed very, very quickly, and the colors would change as you'll see in a few of the shots that I've got. So just a few images while it was down near Balderson. The sky was incredible, and we had a moon up. That bright light in the bottom right, that's the moon. It was still up, and it had no effect on the aurora. It was just stunning. And it would go through cycles. Sometimes it would quieten down, sometimes it would brighten up, but it never turned off. It was absolutely insane, depending on where you look. I'm just going to speed through some of these. Chris, can you fire that one up? This is a view from the panoramic camera of 3 separate images. We go around this circle three times there, and you can see it didn't matter. There's the moon. Didn't matter where you were looking. You got color, and you got aurora. And have a look at the color of the road. On this and on the next cycle, you'll see that here it's reddish. The next cycle shows it as green, and then I think we go back to red again. You could read by this thing. It was insane. I've never seen an auroral display as bright as this. There you go. At this point, most of the sky was green. It was active with rays and that, but the red had gone to sleep, and the green had popped up. And as I say, it was easy to read by this, even though the moon had almost set here. It was
It was just down near the trees, as you'll see when it comes around here. So again, I apologize for noisy images. Like I said, no processing here at all. This is Rico Theta X. There's the moon. And then the last one, it was blood red. The sky was red, the road was red, and I'm looking at myself. Am I bleeding or what? It was insane. I was so excited by this thing that I could have stayed there all night. But it didn't seem to matter where you would be. You would have gotten the view here. Just an absolutely stunning display. So even though I didn't see the tail of the comet that night, I really can't say that I was very disappointed. This was pretty awesome. All right, back to the comet. So 2 days after that auroral display was technically the first night where the comet was visible from our latitude. As I say, you know, location is everything, but also timing. And so this image was one of the first that I grabbed of the comet. I photographed this near my place up in the Lanark Highlands. And as I mentioned, one of the big challenges was the sky had to get dark enough so that you could see fine detail in the tail. Trouble with that is at the comet was still relatively close to the sun, and so you can see this is low horizon cloud down near the bottom there. This image was with the comet only about 4 degrees above the horizon. This is about 3.5. You can see it's starting to dive down. Those black streaks are from a jet that had passed through there just moments before. There we go. So yeah, and then down about 3 degrees or so, getting into low horizon clouds, which was our other challenge. For this object, if you wanted a good view, you really needed a very relatively flat western horizon. This was shortly after sunset, and we needed to have clear skies so you don't get these very distant low-lying clouds in the horizon blocking your view. So there were a few nights like that, but more often than not, it was a challenge. And again, the moon was up, getting close to its full phase at this point in time, which certainly didn't help the situation. The view through binoculars through most of the 13 observations I did was actually very, very nice. Highly recommended for comet viewing. But there were only about 3 nights out of the 13 where I had a positive visual identification on it. Other times I could just make out the tail, but here I could see the actual coma quite easily. 2 days later, this was probably the best night, at least in my area, up in the Lanark Highlands, where I could observe this. The anti-tail was visible to the naked eye. Tail length was at least 15 degrees in length. It was pretty. And as these days went on, every night the comet was getting higher and higher in the sky, so that let us wait a bit. But this was still, I think, 3 days shy of a full moon. So that certainly didn't help. But you can make the anti-tail there, and the tail was actually quite striking. It was easy to see. Thank you. Again, same night as it closed in, you can see compared to the previous image showing the horizon there, that was an exceptionally clear night. No low-lying horizon hugging clouds right down to my tree level. 17th, this was the night, I believe, of the full moon. If I can't consult my notes because Mick won't let me read them and he'll get the hook out on me. Sorry? 16th, thank you. So yeah, a very bright sky, and but you could still see it, you could still make the comet. Certainly in binoculars, it was a bit more difficult visually to see it, so it was a challenge. But after the full moon, we started to get past that, and I think the 19th was the first night where we actually had technically a dark sky window, that being from the end of astronomical twilight to the rising of the moon, and it was 11 minutes long. Not exactly generous, but noticeable on the effect of the sky. The following night was, the following night was even better because now I had about an hour of true dark sky there, and the comet was stunning. This and the 14th were the 2 best nights of the comet, that at least from my point of view.
Anti-tail was visible to the naked eye, and the tail was spectacular. You could see it almost stretching into the Milky Way because the comet was located relatively close to the Milky Way. And this was the last night, this was just last Saturday. This was the last night where I could positively identify the comet in the night sky just with the naked eye. And again, for those that tried to see this thing and didn't have a lot of luck, you really had to know where to look and with a fair degree of accuracy, because for most of the 13 nights, as I mentioned, it wasn't obvious. It wasn't obvious where the comet was, especially if you're in a less than very dark sky. So that was a week ago. I did one more observation. I didn't include an image tonight. 2 days after this, where I could not identify the comet visually at all. I just knew where to look with the binos. I could see it in the binos okay. And since Saturday, the skies have been pretty washy for doing this type of observation. The laser is where, sorry? Skinny black one. Oh, yeah, okay. Oh, there we are. Okay, so I have one more image to show you of the comet. I wasn't quite sure whether I was going to show this or not, because actually for me, it's a work in progress. It's an unusual image, but long story short, for the last year and a half, I've been experimenting with near infrared imaging of the night sky and both terrestrially during the day and celestial objects at night. Near infrared being that light which is not visible to the naked eye, but just beyond the red end of the spectrum. So on October the 5th, when the comet was not at all visible from our latitude during the night, I thought I'd try an experiment which I'd never done before, and that's trying to take an infrared image of this comet during the day. To put things in context, I left this slide up because the image that I'll show you, was taken with my 11-inch Edge HD. That's my big telescope, and it was not at all possible to use that telescope when the sun was either in the low west or in the low east. I've got trees around my property. But during the daytime, the sun was up, and the comet was relatively close to it. In fact, the next image I show you, the sun was only about 7 degrees away from the comet, so pretty close. You didn't really want to aim your telescope too close to the sun. But that field of view is very small. All these pictures of the comet that I've shown you were taken with telephoto lenses. Again, my computer had gone for a bit of a fervor there, and so they were just taken with DSLRs and lenses ranging from 50 millimeter up to 200 millimeter. The focal length on the 11-inch HD is 2800 millimeters, so really zoomed in. And the image I'll show you, basically, if you were to put it there, is not much bigger than that laser pointer, okay? This is what I got. It was very unexpected. I didn't know what I was looking at. This was all targeted by computer. And I knew it was on target because I also imaged the sun and Vega during the daytime with the appropriate filter on for the sun, and the telescope did its thing and put it on target. And then I said, okay, let's see if we can find a comet, and that's what I got. I was shocked by this. I thought, what am I looking at? Is this like a jet that's gone through my field of view? But it's not, because I did manage a number of images with it, and it stayed in the same place. So what got me is that what am I actually seeing here? What am I actually, they can't be jets out of the comet because they're way too symmetrical, for one thing, and even the shape of the central shape of the comet is not what I expected. So I had to give this a pile of thought to see what I was actually looking at. And what I'm thinking, the filter that I used here, you'd like this, Jim, is 742 nanometer bandpass, so just beyond the visible range for us, and basically blocks out everything else, which is why you can image stuff like this during the daytime and you still get a dark sky. What I think I'm looking at here, and like I said, I'm still doing a follow-up here. I'm actually going to try to image this comet again tomorrow, where it's supposed to be quite clear. It's a bit more challenging now because the comet is about twice as far away from us as it was when it did its closest approach to Earth. So I don't know if I'll get it or not, but I'd really like to repeat it, because even that day when I shot that image, there were clouds in the sky, and I had a very short window to be able to do this. So tomorrow, the comet is much farther away from the sun. I think it's on the order of almost 90 degrees away from it, as opposed to 70, or 7 rather. And but it is farther away. It's gotten dimmer, and the orbital geometry has changed in such a way that I'm not going to get a view like this. But to show you what I think this is, actually, can I have a bit of light on the podium, please, Chris? This is an ASI 2600 Pro. So just to give you an idea of what I think this is a little model I've got of a comet and the gas that is jettisoned from it to form its tail. Now, if you look at this, I don't know how well you can see this, but you can see me through this, at least the central part, but not around the ring because it's denser. There's more material there. But we weren't looking at the comet head on. We were looking at it sideways. And so again, a lot of material in the center. And if you see these as shells of gas, you can see why you may see these, what are the wings shooting out denser material there, but you can still see me through the middle part, which is what I think what happened here. And the fact that there's 2 pairs of them, I think is what, I'm only guessing on this one, but I think what this was, this is when the sun was getting blistered, or the comet was getting blistered by the sun. It was only a few days from its closest approach to the sun. So it was getting fried, burping out a lot of material, growing that beautiful tail that you've seen on a bajillion images. And I think what this is just shells of stuff erupting from that blistering it got from the sun. So stay tuned. I'm hoping to get a result, as I say, tomorrow or in the following days. And if I do, I'll share it next month. Thank you very much. Have a good evening. Come around your side. I don't want to.
Thank you, Paul. You can do a whole presentation about it next time. More than welcome, Taras.
So yeah, the auroras couldn't miss the chance, and so not feel sorry for that. It was beautiful location, beautiful show, and so location was West Meath Lookout, probably northwest of Renfrew, closer to Pembroke. It's quite dark. The view is magnificent from the top of the hill. It's a bit of challenge to get to the top of the hill because it's very steep, but from there you can see all the way around, probably slightly below the horizon, and the area itself is in a darker, dark bluish type of light pollution on the chart. So the auroras were really bright. The scenery was beautiful. To our surprise, I was there with a friend, and probably at least 10 to 15 more people knew about the place. They came to see it, and everyone was just wowing, taking pictures, and it feels like a community, that we are here for the reason. We knew the reason, and we know how to enjoy it. It was beautiful. So the same night, the same location, straight to the zenith, though this time, and it's one of the also many pictures, but this one I wanted to show because it has a few objects which were again right about the head, the Andromeda, double cluster, Pleiades. So there was, I think, heart and soul somewhere here. So, and the shape, I think this is like a beak of some bird with one wing and the other wing spread. So just beautiful shape. Amazing. So this was really, it was impression and event of a lifetime. The comet as well. So this was, I believe, right. It was right after Thanksgiving dinner. So same as Jim, I also went to the place. There was Wendover boat launch. It was about the water. And that night, the comet was really bright, easily seen by naked eye. There was actually two fishermen at the pier. One of them, father, didn't catch anything, so he was on his way. I stopped him, seeing his disappointment, because I could hear that he didn't catch it. And I asked, like, when I see the comet, and I showed him first on the screen, then tried to point it in the sky, while his son, holy moly, what is that? Look at that. And he actually saw the comet from the pier. And was really shocked by what he saw. So I did like a short and quick public outreach explaining and showing on LCD what it was. And yeah, so this is the picture from Wendover. You can also see the anti-tail of the comet, and it was quite large, as Andrea and Paul mentioned. It was a bit cloudy though, and shortly after the clouds, the solid clouds overcast came in, and I was lucky to catch this image on that date. Again, something unforgettable. Later on, so this was October 24th, already quite recently. I think it's the same night as you, Paul, were taking the comet, and very similar images you see also with anti-tail now this way, a bit bending this way and not as bright, and getting more like a triangular shape, which doesn't show in this picture well, but I have a more recent stacked version, which you can see like a hint of what it looks like. There is also, not sure, there's somewhere here was a cluster, probably didn't fit in particular this one, but yeah, it was again a really nice night for observing the comet. Yes, yeah, all the attempts I saw them, I saw it visually. The best view was through binoculars though. So it was amazing just to keep looking. The background was quite bright through binoculars and the comet was quite contrast. This was taken on October 18th, if I'm not mistaken, with my Schmidt cast. So like in you, Paul, I tried to image it with a close up with the, probably I used the, I don't remember whether I used the, no, this was without Barlow, but just the planetary camera with a small chip and small pixel size with IMX 290 chip monochrome, which I inverted to show a little bit better of the details. So you also see these jets. This is visual image though, not infrared like yours, but visual, which I tried to do kind of like a sequential stacking with really low exposure for the core itself, then a little bit bigger and brighter to get a little bit of these jets. Instead, the details in the core itself didn't show up. It was just like this blob and the jets streaming out of it. So what's inside this blob, it's difficult to see, but you still can see a bit of the jets coming out of the core. Thank you.
Thanks again, Taras. We will leave this till next month. We will leave it till next month. And so, Richard, please, as usual, your observations and then segue into the challenge.
Thank you. I will try and keep this fairly short. So these are my views of the challenge objects for October. Oh, no, they're not. You've messed up again, Mick. So I don't have my observations tonight, but we have the challenges for this coming month of November. So last month was Perseus, the double cluster, Algol. I never did see Algol in its eclipse phase. We had one observation on the Discord server from Tony Jarrett producing a light curve and a time-lapse video of Algol, but Algol will have a nice minimum around 10:45 tomorrow night, and it's going to be clear. So if you want to see Algol go through its dimming and rebrightening, tomorrow night would be a great night to try. I'm going to see if I can do it. So thanks for everybody who did meet some of the challenges. We had, I think I did see somebody have a fossil footprint as well. That's probably Tony Jarrett too. He's been doing a great job of catching the monthly challenges. And of course, many, many pictures of the comet. So coming up for November, the next constellation down towards the east from Perseus is the constellation of Taurus. And it's a great target at this time of year. The Pleiades, of course, is extremely easy to spot. It's a tiny little cluster. It's sort of one of the clusters that really stands out to the naked eye. It's beautiful in binoculars and terrific with long exposures. Jupiter is right between the horns of Taurus. So a great target now. It's going to be visible most of the night and lots of activity with the moons going on. And there are a couple of other interesting objects that you might like to look at. M1, Messier number 1, is the Crab Nebula, just by the farthest east point of the Bull's Horn. And it's a lovely telescopic target. It doesn't look like too much with the naked eye. You see a little gray smudge, but with a camera, you can catch a whole bunch of color in it and beautiful spikiness. So try for M1. And for a real challenge, we have NGC 1555. And that's Heinz Variable Nebula. And it's called a variable nebula because it actually has a variable star in it, so it keeps changing the brightness of the surrounding nebula. Now, you won't be able to get that within a single month, but it'd be interesting to follow this object over a longer period. So those are your challenge objects for this month. In particular on the Pleiades, just at the time of the full moon on November 15th and 16th, the moon will actually be passing right through the Pleiades. So we have a great challenge opportunity because they are going to be quite different in brightness. So it's really going to be difficult to capture that with the camera. You'll be able to see it with your eye. Your eye is wonderful at catching the whole range of different brightnesses, but see if you can get a picture of that shows both the moon and the Pleiades in the same shot. Also for Jupiter, right between the horns, the Observer's Handbook that as members you are getting every year, this year in the 2024 Observer's Handbook, pages 226 to 232 gives all of the positions and events that happen with the moon, like when they pass in front, when they pass behind, when the shadows go across. And that's the really interesting thing to try and see or photograph. I did it once back, this was in 2023 during the last opposition. I actually managed to catch a point where there were 2 moon shadows on the cloud bands of Jupiter. So that's a really fun thing to keep watching for. And we're still waiting. Okay, thank you.
Stick around. It's not T-core boring yet, is it? No. No. So just to prove that you are not cursed or that I have it in for you. Try again.
Okay. Nope, that's Aquarius. That's not the one. I had a set of slides with Perseus.
Chris, can you refresh? Otherwise, maybe you are cursed.
Probably. Nope, not happening. Some other time, or go on Discord.
Thank you, Richard. Okay. All righty, closing out our tentative program for December. As mentioned, we've got the AGM starting at 7:30, going to maybe 8:15, then a somewhat shorter usual program. Our special guest will be Jenna Hines from the National Office, who will be bringing us a report from the Twilight Zone as to actually what is happening with National after all the reorganisation, what we might anticipate in the future. You may remember we had Majid Naji speak to us back in April, at which point he described a project that they were doing in Montreal to determine the distance to the moon based on timing data from people's photos during the eclipse. So he's coming back in December to give us an update on that. I understand some of you or our members here have shared images with him to aid that project. So let's see how it worked. Richard Taylor will get to present observations, I promise. And then we've got all the usual stuff at the end. Estelle's pick of the month. Remember, the library's out the back here. Mars, Lure of the Red Planet, about which I know nothing, but you can ask Estelle. Fred Lossing Observatory, next members observing party is on Sunday, November the 3rd. Good luck with the weather. Thank you to all the usual doers, people that run the libraries, the FLO, look after our memberships and so on. Thank you as always. 47 plus 47, 94. Okay, so thank you all. Thanks to our speakers, our host, Chasm, whose toleration we've stretched once again, but thank you for the technical support, and Chris up there in the booth looking after the lights and light show. Any complaints to me, like about Google Slides? Thank you. So after this, I need a beer. It'll be at Liam Maguire's over on Saint Laurent, and good food company, and hope we're not too late. So next. Chris, can you click it along? The clickers. All righty. Anyway, thank you all. See you December 3rd, I believe it was. And thanks for all the contributions. 6th.